Alright guys, today we're going to be looking at section 5.2, the integers, and this is a very short section of notes. So we have this sheet that we're going to look at, and we're going to write a few things on the back, and then we're going to do a little interactive activity with the other things that I sent you. And I just about threw my pen in my own face. Sorry about that. Okay, so definitions. We adjoin 0 to a set of natural numbers to form a set of whole numbers. So when you put 0 next to your natural numbers, that's your whole numbers. If you add the negative versions of numbers to your whole numbers, that's integers. So each thing is getting bigger. Okay, obviously you know that if you have two integers that are opposites, then they're additive inverses, and they equal 0 when added together. That's just common sense. When you subtract, it's like adding the opposite. These are your rules for multiplication. Some of you still haven't learned your sign rules, which if they have the same sign, it's positive. If they have opposite signs, then they're negative for multiplying. Same thing applies for dividing. And if you're dividing to get A by itself, then you can multiply C to the other side. Really, no big deal there. So historians tell us that there's no evidence of negative numbers in ancient civilization. Okay, so they didn't even think about negative numbers like the Babylonians and the Greeks. In fact, Greek mathematics were so heavily based on geometry, which involves measuring lengths and distances, they had no need for negative numbers. You know how we say length can never be negative? Well, they were so focused on geometry, they were like, you know, there's no need. They didn't even have a concept of that. Okay, by 7th century, Indian bookkeepers used negative numbers to represent debt. Okay, so all of you future accountants out there, oops, you can't see that. All you future accountants out there, you're the reason we have negative numbers. Okay, and it was from India. Okay, so the Indian mathematicians showed that they had a clear idea of using negative numbers and doing scientific calculations. During the Renaissance, Italian mathematician Cardano, I know I just murdered his name, used negative numbers in his 1545 work, which was a text on algebraic equations. However, a century later, Descartes called negative numbers false roots, and his contemporary Pascal's triangle, believed numbers less than 0 could not exist. It was not until the 18th century, this is crazy, not until the 18th century that negative numbers were generally accepted. So the 1700s. So in the scheme of like time, negative numbers are kind of like new. And to me, that's like kind of crazy. Okay, so we're going to make us a little arrow to flip this over. All right, so let's just make a list of what we have. Okay, so natural numbers are like 1, 2, 3, so on and so on. They're called your counting numbers. Okay, and then you have your whole numbers. Your whole numbers are your naturals and 0. So that'd be like 0, 1, 2, 3, ... Okay? Now, if you want to include more numbers, the next set of numbers you would write would be integers, which is whole numbers and their opposite. So like -3, -2, -1, 0, 1, 2, 3, and we can put dots on each end of this. Okay? Now, rational numbers are integers. so whole numbers and their opposites, and fractions or decimals that terminate, that means end, or repeat. Like terminate would be like 0.5. Repeat would be 0.3 that just repeats, okay? So those are rational numbers. Then over here, so all of these are considered rationals. Irrational are non-repeating and non-terminating decimals. The most famous irrational number is pi, because that's 3.14, and then it keeps on going and going and going and going. Okay? So that's an irrational number. So this leads me into the thing that I sent you with this. You had this piece sent, which has natural and counting numbers. Then it goes into whole numbers, integers, and rationals, because all of them are considered rational. Then you have the small section over here for irrational. So what I would like for you to do is cut all 40 of these little numbers out. And before you glue them, I want you to try to figure out where they go. Now, some of these things can be simplified. Square root of 100 is 10. 10 is a natural number. So I want you to put them on there, and you can pause this so you can do that. And then I'm going to let you check to see if you got yours right. So take a minute, cut those out, place them where you think they need to go, and then we'll check them. All right. So, natural numbers. You should have had 1, 4, 56,912, 179, square root of 49, 5, square root of 1, 10 divided by 5 is 2, square root of 100 is 10, and 9 divided by 3 is 3. So make sure you have those right. The only thing that can be added to the natural numbers that makes it whole is 0, because these are all whole numbers, but 0 is the only thing that can be added. Integers, you would have only added the negative things that would have been counting numbers. So you have negative 56, negative 1, negative 2, negative 56,912, negative 2, that's what this would have become, and this will become negative 8. Okay? Rational has a bunch. Okay? So let's just start right here. Make sure you have 5.5 in this one. 3.14, be careful. It did not say going on and on and on forever. It's just 3.14. Done. 0.6, 5.5 repeating, 0.6 repeating. Okay? Negative 5/7, 15.5 repeating, 0.12345, negative 15.5, 0.12, negative 1/2, negative 16.987, 4/9, 7.4239, 5.55555, 17.5, and negative 6/12. So make sure you have all of those in there. Then in irrational, the only ones that should be in there are pi and negative pi and 3 pi. The negative square root of 77, because that turns into a decimal that doesn't stop or repeat. Same thing with square root of 65 and the square root of 102. Okay, so if you did well with that, congratulations. If you needed a little work with it, hopefully that cleared it up. All right, so that's it for today. Thank you. If you have any questions, let me know.